Oh, okay. So what is the hydrocarbons? The study of hydrogen and carbon is called as a hydrocarbon. So the first organ, according to the Vital Force theory, organic compounds are prepared in a nature but not a laboratory artificially. Point number 4. That is a vital force theory was proposed by Berzelius. Is proposed by Berzelius. Next one. The first organic compound prepared in the laboratory is urea. Urea is prepared from inorganic compound, here compound, that is a ammonium cyanate. When ammonium cyanate undergoing heating to form a urea. So another most important one. In urea, there is a two functional groups are there. Number one is a amide, second one is a amide. Two functional groups. Don't forget this one. This is other names of amines is a, sorry, urea is a carbamide, first name. Second name is a diamine methanol. Second one, diamine methanol. Methanol, it is ketone. Okay, these are the three names are there. Another one, the first organic compound prepared in a laboratory from elements, that is a, which one? Acetic acid. Acetic acid. This is prepared by Kolb. So who is the prepared the urea? Kohler. Urea is prepared by Kohler. Acetic acid was prepared by Kolb. Third one, the second organic compound prepared in a laboratory from elements, that is CH4, methane. This methane was prepared by Berthollat. It is prepared by Berthollat. Another most important, methane is also called as a Mars gas. Mars gas. Mars gas. Mars. The main source is a mud areas. Mud area means Urda Nenalu. Mud area is called Urda. Next one. Most another important one. The Mars gas is explosive gas. This explosive Mars gas is detected in mines by using one important law called as a Graham's law of diffusion. By using as one alarm, that alarm is called as a unseal. So another statement. Unseal alarm is used to detect the Mars gas in mines. This don't forget most important objective question in nature. Okay. Next, another important one. Reasons for separation of organic compound from inorganic compounds. That is it. 7 reasons are there. Number one is it catenation. Number two is it tetravalency. Number three, hybridization. Number four, that is a isomerism. Number five, formation of the multiple bonds between the carbon and the carbon. This is simple one, multiple bonds. Number 6, covalent in nature. Covalent in nature. Number 7 is number 7. Covalent in nature. Number 7. Absence of the orbitals. Absence of the orbitals. These are the reasons for separation of organic compounds from inorganic compounds. Next, taken as a first reason, that is a catenation. What is the catenation? Formation of the straight chain or long chain or rings is called as a catenation. In an entire periodic table, the fourth group elements are carbon family show maximum catenation property. Why it is show the maximum catenation property? Due to high CC or high bond dissociation energy. High bond dissociation energy. For this reason, that is a carbon shows the maximum catenation property. There is a three types of that is a chains are there. Three types. Number one is a long chain. Number two is a branched chain. Number three is a ring chain. Yesterday I'm already showed the structures of these three types of that is a chains. So next one is tetravalency. Before discuss the tetravalency, so there is a you must understand the valency. What is the valency? In earlier definition, I am already told two definitions. Number one is the number of hydrogen atoms present in the molecule is called as a valence. Second one, the number of fluorine atoms present in the molecule is called as a valence. See, hydrogen is equal to the seventh group. Sorry, before I take maybe sorry for that. Next, first of all, we can discuss the position of the hydrogen. This hydrogen position is called as a anomalous position. Why it is a anomalous position? Because of there is a particular position is not there in the periodic table. Why it is not particular position? Because of there is two regions of there. One is the hydrogen is equal to the first A group character of the element. Next one is the seventh A group elements character. How can say this one? See here, I am already right. Hydrogen showing as a two types of charges. One is a positive charge, second one is a negative charge. So here, hydrogen gives the H plus ion. H plus ion is similar to that of first A group elements. First A group elements like sodium plus, potassium plus, rubidium plus, etc. Similarly, hydrogen shows the H minus charge or H minus ion. It is similar to that of seventh group elements like F minus, Cl minus, Br minus, and etc. That's right. This hydrogen is not a particular position is in a periodic table. Clear the point. Any doubt up to here, ma? Any doubt, ma? No doubt. Then you can see this one is the H plus. How many protons are there? Protons are one. How many protons are there? H minus, again 1. So it is equal to the number of protons are equal to the, that is a Z value. What is the Z value? That is a atomic number. Atomic number is equal to the number of protons. But number of electrons are not equal in the case of cations and in the case of anions. So how many electrons are there in H plus ion? Zero. How many H plus, sorry, how many number of electron are present in H minus? Two number. I think you know this type of calculations. Yes or no? How to calculate the number of electrons? So don't forget, I write here one important formula. You must write at the corner of your notebook. Don't forget this. This is a very important in NEET exams. There is a two types of ions are there. Two types of atoms are there. One is a neutral atoms. Second one is a ionic atoms. Ionic atom ion classified into the, one is a cation. Second one is a, how to calculate the number of electrons in cation. How to calculate the number of electrons in anions. Don't forget, you must note down this one. So number of electrons in neutral atom. Neutral atom. Their calculation of number of electrons. Number of electrons. Point number one. For neutral atom. Neutral atom, that is a Z equal to the P equal to the atomic number equal to the number of protons are equal to the number of electrons in neutral atoms. What about the cation and anion? There is a different things here. One is a for cation. For cation. For cation. Number of electrons are equal to the Z minus C. Z minus. What is the Z? I'm already told atomic number. What is the C? C here charge. What is the charge of cation? Here. Okay. Next one. So number 3. For anions, number of electron equal to the Z plus. Don't forget this formulas are very important for exams. Very important for neutral atom. Z equal to the that is a P equal to the electrons. Okay, number of electrons are equal to the Z equal to the P. Number of electrons per cation equal to the Z minus C. What is this C? C is called as a charge. Next one. For anions, number of electrons are equal to the Z plus C. Here, opposite mark, don't forget. Cation means positive charge. Anions means negative charge. If positive charge is there, calculation of number of electron here minus are taken. If anion is there, then it is taken as a anion. Anion means negatively charged ion. If negatively charged ion, then it can add the addition. Why it can call as what is the cation? It is I am already told positive charge. Positive charge means loss of electrons. What about the anion? Anion means loss, sorry, gain of electron. That is a negative charge. Gain means addition. A for addition, C for subtraction. C for subtraction. Or understand for this one, ma? Raise your hands or or send your message to chat box. Or understand, ma? I'm not receiving your answer in chat box. Vandana, yes, yes, yes. Okay, okay, ma. Good, good. Listen, another one. Here, I take the methane molecule. So, how to illustrate the that is a balance with respect to of hydrogen, with respect to of hydrogen. Number of hydrogen atoms. So, here, methane contains how many hydrogens? Four hydrogen. That's why carbon balance is a carbon balance. How many number of fluorine atoms are there? So tell me, ma, what type of charges are there in in H plus and the H minus plus one minus one? It is similar to that of plus one plus one plus one that is equal to the first year group elements. First year group elements. This one is equal to the seventh year group elements. Yes or no, ma? Yes. Here plus one, here minus one. Here plus one, here minus one. That's why H plus are equal to the Cl minus ions. Here how many hydrogens are there? Four hydrogen. That's why in the place of four hydrogen, I substitute the four chlorine atoms. Yes or no? That's equal to the number of chlorine atoms are equal to the number of hydrogen atoms. Therefore, again carbon valency is equal to the 4, is equal to the clear the point. If third one is it. I take the oxygen atom. Tell me about what is the valency of oxygen? 2. What is the oxygen valency? Carbon valency 4. Carbon valency is 4. How many number of oxygen atoms are bonded to the four valency of carbon? Two oxygens. Clear the point. All are see here, ma. I take here carbon 6 atomic number, electron configuration 1s2, 2s2, 2p2. Then here, again note this point, ma. Don't forget here. In ground state, point number 1 here, according to the orbital electron configuration. Point number 1. In ground state, the valency of carbon is just 2. Don't forget. In ground state, ma, ground state, valency of in ground state, valency of carbon is a 2 because of 2 unpaired of electron is there. Clear the point. Number two, this type of oxygen, sorry, valency of valency electrons. I'm talking about the not valency electron. How many valency electrons are there? Valency electron is a 4. Valency is a 2 here. Don't forget the point. Valency electrons 4. Valency is a 2. In ground state. Don't forget the point. So this one takes some amount of energy. How much energy are taken for this one? That is it. This orbital absorb the 501.6 kilojoule per mole. How much energy are absorbed here? 501.6 kilojoule per mole. Don't forget again important point. Observe the amount of energy and going to the excited state. Here excited state. Here one electron, one electron, one electron. Means one electron jump from 2s orbital to 2p z orbital. This is the excited state. How much energy are absorbed here? This energy going to the excited state. In excited state, in excitation, in excited state station, how many number of unpaired of electrons are there? 4. That's why the valency is a 4. Valency is a 4. What about the valency electron here? Valency electrons also 4. Okay, that's why in excited state, valency electrons are equal to the valency. Valency electrons equal to the valency. Clear the point, ma? Come to point. How many unpaired of electrons are there? 4. I take the oxygen here. Oxygen atomic number is 8. Then electron configuration 1s2, 2s2, 2p4, 2p4. Here 2 electrons, here 2, here 1, 1. Here what is the valency of oxygen? 2 number. Valence is depends upon the number of unpaired of electrons. Again, don't forget the point. So how many unpaired of electrons are there? 2 unpaired of electrons. But what about the valency electron? Valency electron is a 6. Valency electrons are equal to 6. Because of 6 electrons is there in outermost orbit. So outermost orbit containing the 6 electrons, then it is called as a valency electrons. Once you see the board, outermost orbit means outermost orbit. So according to the Bohr's atomic model, this is the nucleus. First orbit, second orbit, third orbit, fourth orbit. First orbit containing the 1s, second orbit containing the 2s, 2p, third orbit containing the 3s, 3p, 3d, fourth orbit containing the 4s, 4p, 4d, 4f. Listen careful, ma. I am talking about the orbit. Orbit means outermost cell. Outermost cell. In this case, see the bottom in oxygen atom. In oxygen atom. In oxygen atom, 1s2. What is the outermost orbit? Second orbit. In second orbit containing the how many number of electrons? 6 electrons. 2 electron is a s orbital. 4 electron in a 2p orbital. Second orbit. Number represented as a orbit. Here 2s, 2p. 2s containing the 2 electrons. 2p containing the 4 electrons. So total number of electrons is 6. That's why the valency electrons of oxygen is 6. Tell me what about here? 2s containing the 2 electron, 2p containing the 2 electron. Total number of electron is a 4. That's why it called as a valency electrons. How many valence electron is there? 4. I'm not talking about the valency. Remember, talking about the valency electron. Here 4. So unpaired of electron is considered as a valency. How many unpaired of electrons are there? 2 number. Then see the board mark. In excited state of central atom containing the 4 electrons. So 4 electrons. In these 4 electrons, these are 2 electrons of carbon, 2 electrons of oxygen. These two are overlap with each other to form a one single bond. That is called as a bond pairs. Next one, see the again board. Same oxygen are taken. Oxygen 8. 8. 1s2, 2s2, 2p4. Here, how many unpaired of electrons are there again? 2 electrons. See, this and this again. So remaining are balance unpaired of electron of carbon is bonded with the or overlap with the second oxygen of 2 electrons. 2 electrons. Again this one. See, how many oxygens are bonded to the how many oxygens are bonded to the one carbon atom? 2 oxygens. That's right. According to the oxygen, double of the oxygen, double of the oxygen atom is called as a valency. Is called as a valency. Or understand for this concept, ma, very important one. You can raise your hands or understand, ma. Yes, good, ma. Once I repeat the definition of valency, number of hydrogen atoms, number of chlorine atoms, double of the oxygen atom. Bond with the central atom is called as a valency. These three definitions is earlier definition of valence. What about the modern definition of valency? Simple answer, combining capacity. You know this definition. So what is the combining capacity? Combining capacity of central atom with with other atoms in molecule is called as a valency. This is the modern definition of which one? Valency. See, I taken as a simple again. How many valence electrons are there, ma? Four valence electron in a carbon. Yes or no? Yes. How many bond pairs are there? There is a no bond pairs. But how to form as a bond pair for these four unpaired of electrons? These four unpaired of electrons combined are sharing the with another atoms. See, for example, hydrogen. How many electrons are present in hydrogen? Only one electron. I am already told the that is a H plus and the H minus and the that is a hydrogen. How many electrons? Only one electron. How many electrons are there in a carbon atom? Four unpaired of electron. This four unpaired of electron is bond with the four electrons. Listen carefully, ma. Four electrons of four hydrogens. How many hydrogens are combined to one carbon atom? Four. That's right. Carbon valence is a four. Clear the point. Clear the point. Yes. This is called as a valence. Any doubt up to here, ma? Yes. Come to second region of the organic component. Tetravalency. Tetra means four. So first point I'm already explained. Point number one, the valency of carbon in ground state is a two. Take some amount of energy. How much energy are required for the going to the higher or excited state? 500.6 kilojoule per mole. Kilojoule per. These amount are required to convert all the energy, take that energy, going to the lower energy to higher energy. That energy called as a bond energy. Bond energy. Clear? Going to the excited state. In excited state, the carbon valence is a 4 because it contains the four unpaired of electrons. Clear the point. Another one, note the point or remember in your mind. That is it. Only central atom take the excited state, not other atoms in a molecule. Don't forget the point. Once I repeat this one, the excited state. Which one is going to the excited state? The central atom only. The central atom undergo excited state and showing as a number of unpaired of electron. Then this showing the number of unpaired of electron is bond with the not excited state of the another atoms and form the bond between them. This is the bond formation. Don't forget this important point. Remember in your mind or after completion of the class, you must note down at the end of the page in your notebook. Don't forget the point. Which atom is going to the excited state? Central atom only. Don't forget the point. This is the tetravalency. Any doubt up to here, ma? Any doubt? Any doubt, ma? If we can send the chart, but no doubts, sir. If we doubt, again we can send the Where the doubt is there, or where you cannot understand the concept. Is it clear, ma? Send your answer through the chat box, ma. No doubt. Okay. Next, most important, don't forget this one, ma. Third one is a hybridization. Listen careful, ma. Listen careful. Hybridization. What is a hybridization? What is a hybridization? Hybridization means mixing of orbitals. Which orbital? Atomic orbitals. Not per, not per electrons. Note this point. Which one? Point number one. All of you listen careful. Mixing of atomic orbitals. Atomic orbital. Point number one. Point number two, but not electrons. But not electrons. Okay. But not electrons. Doubt is there. If electrons are mixed, if electrons are mixed, what happened? What happened? If electrons are mixed to form, to form, form, to form which one? Sigma bond under the pi bond. Sigma bond under the pi bonds. Sigma bond and pi bond and pi bond. How to form the sigma bond? How to form the pi bond? These are the very important NEETMA. Number one, lateral overlap. Lateral overlap means head to head overlap. Head to head overlap. Head to head overlap. Lateral and the head to head overlap. Simple example of this one. This one taken as an atomic orbital. S orbital plus S orbital. Both are overlapped to form a hybrid orbital. This one is an atomic orbital. These are called as a atomic orbital. This one is a hybrid orbital. Hybrid orbital. Don't forget my important. Sidewise, here, head to end. Take it as a px, again px to form it. This is the hybrid orbital, or you can take it as a head to head overlap. One px orbital, another px orbital. like this, like this. Pi bond. Pi bond means pi bond formation. Number one, parallel overlap. Number two, side by side overlap. Both are the very important one. Sometimes this lateral means here parallel. Here it can take as a horizontal. Horizontal overlap. Horizontal overlap. Side by side or parallel overlap. Then PZ orbital. Side by side overlap. Here containing the pi bond. Here this bond is a sigma bond. Sigma bond. Another important one. How to form the pi bond? At what time pi bond are formed? Point number three. After formation of sigma bond, again don't forget the point. After sigma bond is formed, then pi bond is a form. Okay. Any doubt up to here? No doubt. Pakka. See. Here, mixing of atomic orbital is called as a hybridization. Then, if not bond with the which one? This electron. Mixing of atomic orbital, but not electrons. If doubt is rises, if electrons are mixed, yes. If electrons are mixed to form a sigma bond and the pi bond. Sigma bond and the pi bond. One is a sigma bond, another one is a pi bond. So here, sigma bond. How to form as a sigma bond? Lateral overlap or head to head overlap. Then it is called as a sigma bond. Next one. If you can also take like this horizontal overlapping of orbital to form a sigma bond. What about the pi bond? Pi bond is formed parallel or side by side over. Clear the point. Side by side to form as a which one? Pi bond. At what condition or what time or the what time at the time of that is the formation of pi bond. After sigma bond is formed, then it can form as a pi bond. This is the important point. Note down this entire the point. See another one. See the both one. This is the point number one. Here you can take it as a second one. How to calculate the number of sigma bonds? Calculation of number of sigma bonds. This is the most important for all competitive exams. Note down number of calculation of number of sigma bonds. Number of sigma bonds are equal to the atomicity. Atomicity minus 1. Atomicity minus 1. So this one is applicable to, tell me one. applicable to non-ring compounds. Non-ring compounds. This is the most important one, ma. NEET exams and all competitive exams. Number two. Point number two. Number of sigma bonds equal to the atomicity minus 1 plus number of rings plus number of rings. This formula applicable to the ring compounds. Applicable to the ring compounds. Ring compounds. See, I take the illustration for this. Illustration. Example is it C2H6. This name is called as a ethane. Clear? Note down at the corner of your notebook. What is the atomicity? Atomicity, again, very important for competitive exams. I think you know this one. Atomicity means number of atoms present in the molecule is called as a atomicity. Number of atoms present in molecule is called atomicity. Don't forget, ma. Very and most important again, objective question. For example, I take this one, C2H6. How many number of atoms are there in that molecule? 2 carbons, 6 hydrogen. Total number is 8. Atomicity of this compound is 8. This is called atomicity of the atomic molecule. This is a of the atomic molecule. How many number of atoms are there? Number of atoms. Number of atoms in C2H6 is 8. That's why it is called as a octaatomic molecule. Total number is 6. Calculate the number of sigma bonds. Number of sigma bonds are equal to the atomicity. What is the atomicity, ma? 8 minus 1. 7. 8 minus 1. 7. C. C single bond H. Single bond H. Single bond H. Single bond C. Single bond H. Single bond H. Single bond H. Note the point and again remember in your mind. All single bonds are a sigma bonds. Another point, ma. Note the point, this one. All single bonds. All single bonds are sigma bonds. Don't forget this one. Okay. You see another one. Point number 2. This is the one extra points. Number two. Number three. Here taken as the carbon containing the one double bonds, two sigma bonds. This is the sigma bond, sigma bond, sigma bond, pi bond. Don't forget again. In this case, three sigma bond, one pi bond is present. Three sigma bond, one pi bond. Fourth point. Here, C, one sigma bond, C triple bond. In this case, how many pi bonds are there? How many sigma bonds are there? Here sigma bond, middle is a sigma bond. So top and bottom of the sigma bond consider the pi bond, pi bond. In this case, two sigma bonds, two pi bonds. Two sigma bonds, two pi bonds. Don't forget the point. Yes. Come to this example, ma. This is the ethane. How many sigma bonds are there? All are sigma bonds. All are single bonds are considered as a sigma bond. Here sigma 1, sigma 2, 3, 4, 5, 6, 7. Answer is a correct. Number of sigma bonds equal to the atomicity minus 1. What about in the case of ring compound? Don't forget this one. In the case of ring, this one is an example of a non-ring compound. Non-ring compound. Next one is it. C6H6. Then it is called as a benzene. So what is the structure of benzene? What is the structure of benzene? This is the C, 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 C. Here one hydrogen, one hydrogen, one hydrogen, one hydrogen, one hydrogen, one hydrogen. Alternative double bonds are present. This is the benzene. So I'm calculating which one? Number of sigma bonds. Number of sigma bonds in the case of benzene. So here number of sigma bonds equal to what is the atomicity? Ma? Atomicity is a 12. How many carbons are there? 6 carbons. How many hydrogens are there? 6 hydrogens. Total number is a 12. So deca, so deca or so deca atomic molecule. Do deca, do deca atomic molecule is a 12 number. 12 number is there minus 1 plus how many rings are there? One ring. How many rings are there? One ring. Minus 1 plus 1 get cancelled. That is a 12. How many sigma bonds are there in this benzene? 12 sigma bonds. See, I am already told. One, three sigma bond, one pi bond is there. Yes or no? Here, one sigma, two sigma, three sigma, four sigma, five sigma, six, 7, 8, 9, 10, 11, 12. Total number of sigma bonds, 12 number. Any doubt up to here, ma? If you can doubt, raise your answer. And send your answer through chat box, ma. Any doubt? Any doubt, ma? Vandana, any doubt, ma? No doubt. Okay. Is it completed, ma? Is it completed, ma? Show your plum. Yes. Here number 2 point, ma, where we take the pi bonds, calculate the pi bonds. Calculate the pi bonds. Number of pi bonds are equal to the summation of total number of individual atoms into B minus 2 by 2 plus 1, where B equal to the valency of each atom in molecule. See the example, ma. See the example. See the example. I take this C2H6 again ethane. So how many number of pi bonds are there in this case? One more. Number of pi bonds are equal to total number of individual atoms. So how many carbons are there? Two carbons. 2 into, I take the valency of carbon. Just I told this one 4. 4 minus 2 plus total number of individual atoms. Second atom is a hydrogen. How many hydrogens are there? 6 into. What is the valency of hydrogen? 1 minus 2 by 2 plus 1 plus 1. Number of pi bonds. Within the bracket, you must know the board mass. Board mass. This is the calculation of mathematics by using as this formula. Don't forget, board mass means B for bracket, O for half, D for division, M for multiplication, A for addition, S for subtraction. What is the formula ma board mass. If calculations are given like this, if calculations are given like this, or if values are substituted like this, you must remember this formula for the calculations. Okay, that is a board mass. B for bracket, O for half. That is a next one. B for division, M for master. That is a multiplication. A for addition, S for subtraction. Your first letter is a B. B is a bracket. First you can do the bracket within the bracket. Here 4 minus 2, 2. 4 minus 2 is a 2. Which 2? Plus 2. That is a 2 into 2 plus next one is a 6. What is it? 1 minus 2 minus 1. Minus into plus minus. Yes or no? Here 6 minus 1 by 2 plus 1. Plus 1. Next one is a multiplication. M is a, don't take that division here. First numerator you must complete it here. That is a 4 plus 6 minus 1. 6 minus 1 minus 6. Plus into minus minus. Minus 6 by 2 plus 1. 4 minus 6 minus 2. Minus 2 by 2. Here, division is there. Minus 1 plus 1. That is equal to 0. Minus 1 plus 1. Both are the cancelled. That is a 0. Means there is a no pi electron. Sorry, pi bonds are not there in C2H6. Taken as an example 2. Example 2. C2H4. C2H4. This name is called as a ethene. Ethene. Then how many carbons are there? 2 carbons. Then 2 into 4 minus 2 plus. How many hydrogens are there? 4. Valence is a 1. Here minus 2. Bus by 2 plus 1. So n pi equal to the here 4 minus 2. 4 minus 2. 2. 2 into 2. 4. That is a 4 minus. Here minus 4. Yes or no? 1 minus 2. Minus 1. Minus 1 into 4. Minus 4. Plus into minus. Minus. Minus 4 by 2. Plus 1. Here n pi equal to the minus 4 plus 4 0. 0 by 2. 0. 0 plus 1 is equal to 1. Structure is a CH2 double bond. CH2. This one, structure of this one. CH2 double bond CH2. I take the C single bond H. Single bond H. Double bond C. Single bond H. Single bond H. Single bond H. How many pi bonds are there, ma? So one pi bond. Tell me sigma bonds. How to calculate the sigma bonds? Number of sigma bonds equal to total number is 6 minus 1 is a 5. 1, 2, 3, 4, 1. Clear the point, ma? Any doubt up to here, ma? See, another important one in the NEET examinations, then ratio of number of sigma bonds and the number of pi bonds in C2H4. Very, very important objective question, ma. Question is a, what is the question? Number of sigma bonds and the number of pi bonds, sigma bonds in methane. 5 is to 1. 5 is to 1. Same question, same question. Ratio of number of sigma bond is to, sorry, number of pi bond is to number of sigma bond in C2H4. Don't forget again. Question is given like this. Number of pi bonds, number of sigma bond. 1 is to 5. Here 5 is to 1. Most important objective question in the case of A. Clear? Any doubt up to here, ma? Any doubt, ma? So I completed the number of sigma bonds, number of pi bonds. See the bottom. Another formula is also there for calculation of number of pi bonds. See, another simple trick for calculation of which one? Number of pi bonds. Number of pi bonds equal to the 2n plus 2 minus number of hydrogen by 2. Number of hydrogens where n equal to the number of carbon atoms. Number of carbon atoms. For example, again same compound are taken. C2H4, C2H4. Any doubt, ma? C2. Number of, that is a 2n plus 2 minus NH by 2. See, how many carbons is there? 2 carbons. That is a n pi equal to 0. N pi equal to the 2 into 2 plus 2 plus 2 minus 4. How many hydrogens are there? 4 by 2. That equal to the 6. Yes or no? 2 2s are 4. 4 plus 2, 6. 6 minus 4 by 2. That is a 2 by 2 equal to 1. Okay. Take like this. So again you can take it as a C2H6. C2H6. So how many hydrogens are there? 2 hydrogens. That is a n pi equal to the 2 into 2 plus 2 minus 6 by 2. That is equal to n pi equal to 6 minus 6 by 2. 0 by 2. That is a 0. Any doubt up to here, ma? Or understand, ma? Is it completed, ma? Yes. These are the most important for NEET exams and also important NCRT questions, also important IP also. Okay, okay, ma. Okay. Tomorrow I will continue, ma, because we are going to the hospital. Okay, no doubt. Okay, thank you, ma.